Hello. In this video, I'm going to go through an example of computing a confidence interval for a mean. So I have this example here. It says that an FDA guideline is that the mercury in fish should be below 1 part per million. And then we have a sample of tuna taken from some different stores in New York City. So the sample values themselves are shown down below here. And we want to construct a 98% confidence interval estimate for the mean amount of mercury in tuna in New York City. So we're using the information about the tuna that they sampled from to figure out how much mercury is in tuna sort of in general. So first question, are the requirements satisfied? We talked about this in class, but in this case, it's really not clear whether the requirements are satisfied. The first requirement is having a random sample, in particular a simple random sample. And here it says a sample was taken, but it actually doesn't tell us anything about how it was chosen. So I would just make note here that if this wasn't a random sample, then we can't actually do an interval estimate. So we're hoping it's a random sample. And secondly, we need to have either n greater than 30, which is definitely not true here because our n value is how many items are in the sample, and that's just 7 in this case. Or the population is normal. And by normal, I mean normally distributed. And this is also not clear in this problem. So it's reasonable that maybe the amount of mercury in tuna would be normal distribution, but that's not really clear here. So again, if that's not the case, then we would not be able to proceed. In any case, if we assume that these are true, then the second determination is, do we know sigma or not? And in this case, we do not. And as we talked about in class, that's usually the case, that normally you don't know what the population standard deviation is unless we were able to determine that from some other study or something like that. So since it's not known, when we go to find the critical value and when we go to compute the margin of error after that, we're going to have to be using the t distribution. This is that student t distribution instead of the normal distribution. So this same idea is true here. I imagine kind of cutting off the edges. The area in the center here is going to be our 98% confidence level, so 0.98. And we talked about it for this student t distribution, we're going to use the t inverse function with the 2t for the two tails. The two inputs for this function were the alpha value, which in this case is 0.02. Right, remember that is 1 minus our confidence level. And then the degrees of freedom. And the degrees of freedom in all of these problems is n minus 1, meaning 1 less than the number of things in the sample. So in this case, this would be 6. So I'm going to plug that into Excel and compute that out. So I get a critical value of 3.14267. And I'm just going to use all the decimal points that Excel gave me. I can always round my answer later. All right, once we've got the critical value, we can compute our margin of error using that margin of error formula, in particular for mean. There's a different margin of error formula for our proportions. So this is T alpha over 2, which would be our critical value, times S, or the sample standard deviation, divided by the square root of n. So here we've got 3.14267 times, now S we need to compute still. I don't know what S is. That was not given to us in the problem. N we know is 7, so I can put in a root 7 here. But S is the sample standard deviation. So I need to come back up. Here's the actual sample we got of all those values. I need to compute the standard deviation here. In some of the problems, the standard deviation will just be given to you, but here we have to compute it. So this is just going back to chapter 3. I'm going to go into Excel, type in all of these numbers, and then compute the standard deviation. Okay, so here I have just the list of the numbers from this problem, and I'm going to compute the standard deviation. If you don't remember, this is equals STDEV, so standard deviation, STDEV. dot, and then we want to pick the sample one, so that's the .s version rather than the .p version, which is for populations. So I'm going to use that sample standard deviation function in Excel, put in the data values that we were given in the problem, and then press enter. And that standard deviation here I'm going to put into the formula for the margin of error. All right, so now I've got the critical value plugged in, the S plugged in, and the N plugged in. I'm going to use a calculator, or you can use Excel to compute out this product. And here I've written this down just with 6 decimal places, 0.434087. That would be our margin of error. And then our interval estimate, or our confidence interval, we're going to take X bar, which is our sample mean, and we're going to add and subtract the error. So our interval would be from X bar minus E to X bar plus E. So we need to compute both of these. Now, E we just computed. X bar is another thing that we were not actually given in this problem. So again, some problems, the problem itself will tell you what the sample mean is. In this case, we need to compute our own sample mean based on that data. So if I go back to my Excel file, I've already got the data typed in there. I can just compute the mean, and our mean calculation was done with the average function in Excel. So I'll use average, put in the data, and here is my mean, 0.71857. So I'm taking 0.71857, subtracting off the margin of error, 0.434087, and then adding that. And again, throwing that into a calculator or doing that on Excel. And there are various different rounding rules for these. I would say just follow the instructions in the textbook. Because our original data had 2 decimal points, it might make sense to go to 3 decimal points here. So 0.284 to 1.153 in this case. So the interpretation of this result, this gets into how do we word our answer for confidence intervals. We could say here that we are 98% confident that this interval that we came up with here will contain the true mean value for the amount of mercury in tuna in New York City. And in particular, if we come back to the description, the FDA says that it has to be below 1 part per million. So this sample, our estimate for the population, it could be less than 1 part per million because that is part of the interval, but it could also be more. So this result we're getting here is concerning. This means that the tuna in New York does not seem to meet the FDA guidelines, or at least it might not meet them. That's it for this video. In the next video, I will show how to do the same kind of process when we're trying to estimate a standard deviation.